So you had section 13-2, numbers 3 to 36, multiples of 3. Okay, here we go. Five x squared equals 35. Okay, we are using the square root method. So we need to get this x squared by itself. I'm going to divide both sides by 5. X squared equals 7. I'm going to square root both sides. This would be x. There are two possible answers, the positive and negative square root of 7. And that's it. Number 6. 2x squared equals 5. We need to solve for x. So we get the x squared term by itself. So x squared equals 5 halves. We're going to use the square root method. We're going to square root both sides. That'll give us x. Since we're looking for all possible solutions, there's a positive and a negative radical 5 halves. Yes, we cannot have a radical in the denominator, so we're going to rationalize. Multiply the top and bottom by radical 2. So x equals positive and negative radical 10 over square root of 4, which is the same as positive and negative radical 10 over 2. Yeah, we're solving for x, so we're writing it in set notation, all the possible solutions. Number 9. 3x to the second minus 49 equals 0. Okay, a little more challenging. We need to get the x squared by itself. I'm going to get rid of the minus 49. So if we add 49 to both sides, we'll get 3x to the second equals 49. We'll divide both sides by 3. X squared equals 49 thirds. I'm going to use the square root method. Square root both sides. X equals positive and negative. I can square root the 49, that's 7. I can't square root the 3. We need to rationalize the denominator. Last step. So that'll give us positive and negative 7 radical 3 over, this is 9, so the square root of 9 is 3. Number 12, same idea. 12 says 49 m to the second minus 16 equals 0. Oh yeah, it's possible to factor, but because this section is on square root method, that's what we're going to use. Yeah, this one is factorable. We'll use the square root method though. There are times when factoring is not a good idea. Actually, it's not possible to factor, like in the previous problems. So we'll divide both sides by 49. So m squared equals 16 over 49. If I square root both sides, m equals positive and negative. Square root of 16 is 4. Oh, we can square root the 49 too. 7. There. Number 15. 15 says 100 x squared minus 5 equals 0. Yes, again, this is factorable, I think. 5, 20. Oh, maybe not. Maybe not. Oh, I guess it could. That's okay. Yeah. When you get to problems outside of class, the method is going to be up to you, but you have to learn all 4 methods. That way you have the flexibility of actually being able to choose what you want to do. Some methods are better than others. 5 over 100. Oh, okay, that's what I meant by the factoring. This can be simplified. Yeah, like up here, we could have factored out a 5. So same here, we can divide both of these by 5. 1 over 20. I'll square root both sides. X equals the square root of 1 is 1. Square root of 20. I can square root that, but I can factor it. 4 and 5. So that's positive negative 1 over 2 radical 5. We need to rationalize. We're going to multiply top and bottom by 5. So positive and negative radical 5 over, this is 5. So 2 times 5 is 10. $18. Oh, okay. D plus 3 squared equals 21. This right here, that whole thing is a square term. We can square root already. That'll give me D plus 3 equals positive or negative square root of 21. All we gotta do is get D by itself now. Subtract the 3, negative 3 plus or minus radical 21. And that's it. So there are actually 2 answers. Yeah. The first answer would be negative 3 plus radical 21. The second answer is negative 3 minus radical 21. Yeah. If you would have to punch it in the calculator to get a number, but this is the most accurate way of writing it out. Yeah, otherwise you would have rounded too soon, and yeah. Okay. 21. 21 says x minus 13. That whole quantity squared is equal to 64. This right here, the whole thing is a square term, so we could square root both sides. That'll give me x minus 13 equals positive and negative. Oh, we can square root the 64. That's 8. All we gotta do is get x by itself now. Add 13 to both sides. X equals 13 plus or minus 8. Okay, so unlike this though, where we had to leave it because the square root of 21 is ugly, this one is nice. So we can do it. 13 plus 8 and 13 minus 8. This would be 21. This would be 5. Those are your 2 solutions. Yeah, we'll go as simple as we possibly can. I mean, this is correct, but it's not in simplest form. This is what we're looking for. $24. X plus 9, that entire quantity squared, is equal to 34. Okay, the square term is by itself on the left side. We're going to apply the square root to both sides. That'll give us x plus 9 equals positive and negative 34. Now, yeah, I guess we could have applied the positive and negative here on the left side, but they kind of sort of cancel out. Yeah, we're just going to account for the square root here. Yeah, we'll get a positive answer, we'll get a negative answer. Subtract 9 on both sides. X equals negative 9. Oh, square root of 34. Sorry. Negative 9 plus or minus square root of 34. We can't simplify, we can't add because this is in radical form. We'll just leave it there. You have two solutions. Yeah. If you rather write it like this, where they're separate, that's fine, but this is the shorthand. (27) says y minus 5 squared is equal to 20. We'll square both sides. Y minus 5 equals positive or negative square root of 20. We'll get the y by itself. Y equals 5 plus or minus, the 20 can be factored into 4 and 5. So 2 radical 5. Simpler radical. Number 30. Y squared plus 10y plus 25 equals 121. If we try to get this y squared term by itself, that'll move these two terms to the right-hand side. But the problem is you'll have a variable on both sides thereafter. There's got to be another way of doing this. You know? We can factor. Yes, I know I said we shouldn't factor, but you'll see. Yeah, we're not gonna do like the last chapter where we get it in standard form. We'll factor this side. It comes out to plus and plus 5 and 5. Notice the parentheses are the same. The factors are the same. So that'll give me y plus 5 squared is equal to 121. And we're back to doing problems that look like this. We can square root both sides. Y plus 5 equals positive or negative 11. Get y by itself. Negative 5 plus or minus 11. This can still be simplified. We can do the add and subtract. So negative 5 plus 11, negative 5 minus 11. In which case, this is 6, this is negative 16. Those are your two solutions. Number 33. 33 says, I'll use x. X to the second plus 16x plus 64 equals 15. We're going to factor this. X and x plus and plus, we need 64. 8 and 8. Yep. So when we do the factoring, it's going to end up where the parentheses should be the same. It has to be the same. X plus 8 squared. If it's the same, then we can apply the square root method. You know, that'll cancel out the radical. I mean, not the radical, but the exponent. You know, so that would be x plus 8 equals positive and negative radical 15. X equals negative 8 plus or minus radical 15. Okay, last one. 36. N to the second minus 8n plus 16 equals 50. N and n, we need a positive 16. So the sign's got to be the same. Since we need a negative 8 in the middle, it's minus and minus. Two numbers that give us 16. 4 and 4. That'll give us 8 in the middle. Okay, so n minus 4 squared is equal to 15. Now we can apply the square root method. positive and negative radical 15. Just gotta get n by itself. Add 4 to both sides. 4 plus or minus radical 15. Hey, hope that helped. We'll see you in the next one.